Today I'm going to be talking about how content resequencing might improve student outcomes in introductory statistics courses. These courses are typically required and might be the first and/or the last statistics courses taken by these students, and they have limited mathematical prerequisites. While students are more often consumers rather than producers of statistics later in life, we still want them to have statistical literacy, and we still want them to be able to properly incorporate statistics into the scientific process. However, some courses focused on rote exercises, arithmetic, distribution tables, and there were calls to action as far back as the 1990s. However, despite all these previous calls to action, there's still evidence that changes in course content or pedagogy as late as the 2010s just haven't occurred. Even technology use appears to be lacking at various institutions. Sometimes you have ineffectual technology use, lack of technology use, it's taught as an add-on. It just doesn't feel integrated, and instead we still have manual calculations, and failure rates in classrooms such as these can exceed 40%. The U of A was right there. We had this required course. Our prior structure was arithmetic heavy. We had distribution tables. We tried to incorporate technology, and that improved our failure rate a little bit, but we still had a long way to go. And so we thought to ourselves, are we considering the learner? And everyone should ask, to what extent do statistics teachers, do we consider the learner as well as the discipline? And content sequencing can do that. There is no best sequence, but Posner and Strike had this fundamental belief that content can be sequenced in a manner that is consistent with reality, that is natural, that incorporates the learning process. We need to sometimes break from the textbook sequence that moves from easy and familiar to difficult and has this statistical inference roadblock when we reach sampling distributions and doesn't follow the scientific process. Connected processes seem disconnected to the learner. Chance and Rossman mentioned this in 2001, and in combination, their 6 points of agreement suggest that statistical inference should be discussed early and revisited often, repeated in different settings several times during the course, so that we have time to absorb the material and time to resolve faulty reasoning before students leave our room. Malone says something similar and describes two alternative sequence models. They're different yet markedly similar, just like the U of A's model. So on the left-hand side, we have our previous traditional sequence, and on the right-hand side, we have our current resequenced model, which is what we utilize now. We utilized a backward design to set key goals that would be the focus for the new course, and a mixture of learning-related sequencing and content-related sequencing, which resulted in a model that is quite similar to the Winona State model. We continued technology. You have to have buy-in, though. It helped for us because we had a coordinated course, but to have buy-in for instructors, it helps to have a creation of standalone materials that are apart but still utilizing the textbook. And as far as evaluation, we went ahead and evaluated that our enrollment overall at the university had increased greatly. It also had increased greatly in our course, but ACT scores remained relatively similar, and you can read further details about that in a paper I will cite. But basically, student success increased, student learning increased, student perception improved. And generally speaking, that's what we want, because if student experience improves, that will shape the future statistical behavior of each individual student and consequently how statistics are utilized in our society. So if you are thinking about resequencing your course, email me. There are further details in some of these references, but definitely consider it. If you're wishing to break from tradition, consider mixing it up.